In this video, we will try to understand a LeetCode question, LeetCode 32. Given a string consisting of the characters opening parenthesis and the closing parenthesis, find the length of the longest valid well-formed parenthesis substring. Okay, so given some string of characters, let's say like this, we are required to find the length of the longest valid parenthesis substring, which in this case is the complete one. And the rule for finding the correct substring would be a substring is considered valid if every opening bracket has a corresponding closing bracket and they are nested or sequenced directly. Nested means like this this substring is nested inside this string, and sequence correctly means a closing bracket should only come after an opening bracket. For example, in string closing bracket opening closing opening closing closing, the longest valid substring is this one. Why? Because it is sequenced correctly. Because in this substring, every closing bracket comes after every opening bracket, which has a length of 4. So let us try to understand what we are doing here. Let us dry run first. Let's say we are given a string which is like this. So what we do is we create a stack, okay, and we initialize the stack to -1. Why -1? -1 marks the boundary of the valid substring. So let's say we assume that from here we start our valid substring, and the index value of this character of the string is 0. So the boundary of the valid substring would be -1. So we assume that the valid string starts from this index. Under that case, we mark that the boundary would be the index value just to the left of it. So we initialize the stack with -1 as the boundary index. And we assume that the current max length is 0. Makes sense? Okay. So now at the index value 0, we find an opening bracket. When we find an opening bracket, we'll push it into the stack. We'll append it into the stack. So we'll push the index value to the stack. So now the stack is like -1, 0. Makes sense? Now we go to I equal to 1. We again find an opening bracket. So we again push this to the stack. So we get -1, 0, 1 in the stack. Makes sense? Then we have I equal to 2, where we find a closing bracket. So we pop the stack. So earlier the stack was -1, 0, 1. After popping it, it became -1, 0. And then we find the length using current index value minus the last value of the stack. So 2, 0, which is 2. If the current length is greater than max length, we'll say that the max length is current length. So we get max length is 2. Then at I equal to 3, we find an opening bracket. Now, since we found an opening bracket, so we'll push the index value of this opening bracket to the stack. So we get -1, 0, 3. At I equal to 4, we find a closing bracket. So we'll pop from the stack. So now our stack would become -1, 0 from here to here. Under that case, when we pop from the stack, we'll try to find the length, which is the current index value minus the last value in the stack right now after the popping happens, which is 4, 0. So the length becomes 4 minus 0, which is 4. So the max length, since max length earlier was 2, now we got length as 4, so max length will be assigned the value of 4. Then after that, at index value 5, we get char to be and closing bracket. We see if the stack is empty or not. If not, current value minus the whatever the last value of the stack is, which is -1 in this case, 6. So the now entire string from index 0 to 5 is valid. So our final answer would be 6. Make sense? But let us try to understand what's happening. So basically the stack always keeps the track of the unmatched positions. That means in the given example, what stack was actually doing was it was keeping the index values like the boundary value or 0 or 1 or something like 3. What are all these? This is 0, this is 1, this is 2, this is 3. So the stack is actually keeping the track of all the unmatched opening bracket positions. The most recent invalid positions, the boundary. Yeah. So the stack is keeping track of two things. The boundary, that is the most recent invalid position, which in this case is -1, because like boundary is always one index before the actual valid string, and all the unmatched opening bracket positions. When we match a closing bracket, we pop the stack. If something remains in stack, that means there is still a valid boundary position. So we compute length from that boundary. So for example, here we witnessed the first closing bracket at index value 2. Under this case, what did we do? We popped the last index value, which is 1. So we popped 1. After popping 1, what remained in stack was -1, 0. After that, we subtracted 2 from 0 to find the current valid length, which is 2. We then witnessed the next closing bracket at index value 4. Till then, our stack was -1, 0, 3. On witnessing the index value 4, we popped 3 and our stack became -1, 0. Under that case, we subtracted 4 from 0 to get 4 as the valid index position, valid maximum length. Then we again witnessed the closing bracket at index value 5. At that point, we popped we popped the stack, and then the stack became -1. Since the stack is not empty, that means we still have a valid boundary, valid opening bracket left out. So we'll subtract 5 from -1. We'll subtract -1 from 5 to get 6 to be the valid maximum length for this problem. So the stack becomes empty. It means the current closing bracket is invalid. So we mark this index as the new boundary. Why didn't we mark the next index to this closing bracket as the boundary? Because boundary is always one index less than the contiguous valid maximum length substring according to the question. So because this closing bracket is invalid, since we didn't find any valid unmatched closing opening positions, we mark this as the new boundary. What are we really doing? We are dynamically tracking the leftmost points from which a valid substring could start. At each closing bracket, we try to close something. If we succeed, we measure how long the valid region extends. If we fail, we reset the starting boundary. Make sense? Now, you might have some questions. Let's answer those questions. So, the question is about finding the longest continuous segment that forms a correct parenthesis expression. Correct according to the question. Now, there are two key difficulties in solving the question. First, parentheses must match correctly. Second, the substring must be contiguous. We cannot skip characters. Parentheses must match correctly. That means the sequence should be correct and the substring should be contiguous. The first question is, why do we use tags of indices and not the brackets themselves. Like, think about what a substring, that is what makes a substring valid. A closing bracket must match the most recent unmatched opening bracket. The closing bracket must match the most recently unmatched closing bracket. This is the LeetCode structure that is exactly why stack is used in this question. And why are we using indices instead of characters? If we store only the opening brackets or closing bracket symbols, we could check matching, but we cannot compute the length directly. By storing indices, when a valid pair is formed, we can compute current index minus last matched index as the valid length. This gives the length of a valid substring ending at current position. Why push -1 initially? We need a virtual boundary before the string starts. Suppose the whole string is valid, like opening, closing, opening, closing. At the last, index 3, after matching everything, the stack contains -1 only. So the length 3 minus -1, which is 4, gives the correct full length. Without -1, we lose the left boundary. And why do we push index when stack becomes empty? If we encounter a closing bracket that has no matching opening bracket, that position breaks validity of contiguous or continuousness. No valid substring can cross the index. So we reset the base boundary to that index. Makes sense? So it's a fairly simple question. Let's code it out. So this is the solution. So over here we are defining the function called longest valid parenthesis, whose input is string s and output is the integer, which is the maximum length of the possible substring which is valid. So as I told in the explanation, we push -1 initially in the stack as the initial boundary. The max length is 0 and the length is 0. Then we traverse the entire string. If we find an opening parenthesis, we push it to the stack as a valid uh, boundary, as a valid opening parenthesis for some contiguous string, substring. Else, if we encounter closing parenthesis, we pop uh, it. We pop from the stack as to say that we found a closing bracket, and thus opening bracket is consumed. And under that case, we find the length to be I minus stack.peak. If the stack is empty, then we'll simply push I as the new boundary position. Otherwise, we'll find the length, and then we'll find the maximum of max length and length. And then it's simply written max length. That's it. Thank you. Bye.